Well, thanks very much, Kate, and thanks, Penny, for the fantastic introduction to today's event. And so what I'm going to do here is do essentially a very quick global update, sort of almost looking in four parts, looking at global sort of issues, looking at what's happening nationally down here at the local level, and then bringing in some other issues which have already been touched on by Penny and also Kate. So in doing this, I'm recognising that many other individuals and organisations have contributed to the work that I present here. What I'm trying to do is draw the best information together to provide this snapshot. So one of the key things, of course, is what's happening with our carbon dioxide concentrations. This is a graph coming from the Global Carbon Project, which is run out of Canberra with Pep Canadell, just up the road from ANU. And what this shows is billions of tonnes of carbon dioxide per year. And I've shown this before at previous updates, but this is the updated version with this year's sort of numbers sitting up there. And you can see that 2019, our emissions increased by 0.6%. But wasn't as much as the previous year, which went up about 3%. But nevertheless, is that in spite of the fact that we've got the Paris Agreement commitments which are intended to take our emissions down, as Penny said, they continue to go up. So we have a really significant challenge ahead of us because this issue is not about levelling off emissions, it's about taking those emissions down to net zero and taking them down to net zero by 2050 or 2045 to keep to a 1.5 degrees target. So if you look at the scale on that graph, you'll just see what an enormous challenge that is. Now, of course, when we produce carbon dioxide and other greenhouse gases that accumulate in the atmosphere, we expect when we're producing such enormous amounts of these, it will in fact show up in atmospheric concentrations, as it has done continuously for decades now. And so last year was the highest carbon dioxide concentration ever recorded within human history, of course. Today, it's 413 parts per million. When I was born, it was 317 parts per million. So that's the change that's happened in one lifetime. So it's not just carbon dioxide, but we also have record levels of methane, record levels of nitrous oxide, and record levels of some other greenhouse gases such as sulfur hexafluoride. And all of these contribute to global warming. And so what we're actually seeing in terms of warming across the globe, this is a graph coming from the UK Met Office, and going back to 1850, so it's 170 years of records there. And what it shows is that 2019 was the second warmest year on record. The warmest year was 2016, so we're breaking these pretty regularly or nearly breaking. And it was only just a shade less than 2016, which is particularly notable because this year was not an El Nino year when it tends to push up global temperatures. So we're already 1.1 degrees above the pre-industrial average across the globe, and we're accelerating that temperature increase. And the UK Met Office's projections over the next 5 years is that one of the next 5 years, there's a 10% chance that we'll actually exceed 1.5 degrees globally in that year. So we're racing towards that Paris Agreement target when, on average, the global will warm at 1.5. So the rationale for thinking that we've got time to act is actually very limited because we don't. So of course, when we're starting to think about energy budgets, what happens on land, which is what we tend to feel is important, but what's really important is what happens in the oceans. And this is some work just recently done which just updated the ocean heat content, the different colours, the different depths of the ocean, and you can see that the aggregate temperature increase is not just going up, but it's accelerating, it's going up faster and faster over time. And in particular, we see really significant heat content increases in the top surface of the ocean, and that's crucial because that's actually driving reduced oxygen content in the ocean, increased marine heat waves, reduced marine productivity, increased coral bleaching, and similar events. So our beautiful coral reefs are indeed a threat. So if we actually look at what also happens in terms of sea level, so as the ocean warms, it expands. We've known that. We can do that experiment in a high school laboratory. What happens when we actually do that across the globe is we actually get sea level rise adding to what's going on with the melting of the glaciers and the breakdown of the Greenland ice sheet and Western Antarctic Peninsula. And so what happened last year was again, we had record sea level, and it's going up around about 3.3 millimetres per year at the moment. So that sea level rise is increasingly a concern, because as we understand more about what's going on, we get more concerned, because the extreme projections just grow and grow. As climate change impacts, our concern grows because things are happening faster than we thought they would. And so when we actually start to look at what is happening in terms of sea level rise, that recent assessment of experts across the globe assessed that by 2100, our planning right now needs to look for a 2-metre increase in sea level rise by 2100. Not 1 metre, but 2 metres. And that's absolutely huge. And if we go out to 2200, the sea level rise they're recommending to be taken into account in planning exercises is 7.5 metres. And it keeps on going after that. It doesn't stop at 2200, it keeps going for centuries. So we also have seen in the last year new modelling which has improved coastal elevation mapping. And what that has showed is that it tripled the number of people who are assessed as being vulnerable to sea level rise. Not 10%, not 30%, but tripled the vulnerability as assessed by these scientists. And in particular, under a high emission scenario, by the end of this century, we were looking at something like 630 million, almost 2/3 of a billion people who were going to be living below the level of annual floods in their location around the coasts. Now, to think that this is not going to impact on us in all sorts of different ways, including through enforced migration, is in my view naive. If we are heating the atmosphere and the oceans in such a way, it's not surprising at all that we're increasing our extreme events. And Penny mentioned the insurance industry, and this is what they're facing. So this is a graph straight from Munich Re's website, and what it shows is down the bottom, it shows climatological, hydrological, meteorological, and geophysical events. So these are insurable events that are happening, reported by the industry. And you can see the top is the aggregation, the sum of all of those. And again, it's not just going up, but it's going up faster and faster over time. So it's accelerating in its intensity. And you can see that this year was only fractionally below the worst on record. If we actually start to think about temperature, Australia, and think nationally, Australia last year had the highest temperatures on record, so 1.52 above the Bureau of Meteorology's baseline. So that Bureau of Meteorology's baseline is 1961 to 1990. If you try to think about a pre-industrial baseline, you have to add about 0.4 to that number. So if we're dealing with a Paris Agreement type number, where essentially last year was something like about 1.9 degrees above that baseline last year. And that's the mean temperature. The daytime temperatures, as I'll show you, were higher. We saw the hottest summer record ever recorded in, last summer, as in 2018-19 summer. We had heat waves across several months. It wasn't just the summer months that we had heat waves. We had the hottest day ever recorded in Australia in December. And that was 4.09 degrees, beating the previous record, which had only been set a couple of years before, which was 4.3 degrees. And the following day, it was beaten with 4.19 degrees. So this is the temperature averaged across the whole of Australia, and it was 4.19 degrees. Almost mind-boggling hot. And the following day almost beat that record as well. So we were just a shade off actually having 3 record-breaking days in a row, a hat trick, if you want to think of it like that. If we actually look at the maximum temperatures in the daytime, which are crucial in terms of things like fire risk, in terms of livestock productivity, in terms of human comfort, or evaporation in terms of water resources, etc. You can see from this graph on map that huge areas of Australia were hottest on record. And the only places that weren't hottest on record were this big area in the northeast, and also a little area down there and a few spots down here. But this was caused by Tropical Cyclone Trevor, which dumped huge amounts of rain. They had record-breaking rain up in the north, and as you'll remember, that was, we lost something like 500,000 beef cattle up in that area because of the rain and the cold weather that brought with it. This is in summer in Australia's tropics, and animals are dying from cold. So So this is like, in a sense, you know, like a really significant aberration. If it hadn't been for Cyclone Trevor taking that path, pretty much all of Australia would have been on hottest on record. Over here, this was Tropical Cyclone Veronica, which cooled things down just a shade there. So if we actually start to think about that integrating or interacting with rainfall, we see a very interesting pattern emerging. So the only places that were cooler, or a little bit cooler than the rest of Australia, were these places here, which had big dumps of rain, and this place over here. The rest of Australia had incredibly dry conditions, and averaged across Australia, we had the driest on record. So it was 277 millimetres averaged across Australia. The previous lowest on record was the Federation drought, when Dorothy McKellar wrote about land of droughts and flooding rains, and that was 314 millimetres. So we broke that record by a tremendous amount, unfortunately. So we had the main driver, but not the only driver, this was the record positive Indian Ocean dipole event, and unfortunately these are projected to increase, possibly up to fourfold, as climate change develops over the next decades. So these sorts of events are likely to happen more and more frequently in our future. Many places in Australia are experiencing the worst drought. We've actually seen that broken in some places, but not everywhere in Australia in recent days. We had towns and rivers running dry. We had the massive fish kills this time last year in the Darling River and others. And so this impacted in all sorts of ways, this dry conditions. And we also, however, as I mentioned before, had those wettest on record events up in the northeast of Australia. So what I'm just drawing there is just your attention to that link between rainfall and temperature, that they are linked, these aren't independent things. So what I did here was just plot it out, in this case for southern Australia, and in this particular graph, it's the pre-1950s data, and I simply plotted out for each year, so each dot is a year, the rainfall and the temperature for each of those years. So each dot is just located on this rainfall and temperature space. And then I drew a line of best fit, just a simple linear regression between them, just showing that there's a strong linear relationship between temperature and rainfall. So down on the bottom end here, you've got wetter and colder years. At the top end, you've got hotter and drier years. This is the pattern for the 1950s, up to the 1950s. If we actually then look at splitting up into three other periods, so that's the 1950s to the year 2000, and then post-year 2000, we see very similar relationships. So the relationship between temperature and rainfall is extremely stable across these different periods. So the slope of that line, the regression line, is very, very similar, almost identical across those different periods. So it's a very stable, robust relationship. But the difference is that the average temperature has gone up. So when we overlay those ellipses on top of each other, we can actually see how radical a change in the operating environment we've had. So this is the operating environment, the trade-off between risk and productivity that, say, a farmer has to manage, and Verity will be talking about that later, or a water resource user has to manage, etc. And you can see that the operating environment, as indicated by that blue ellipse down the bottom, is almost completely different from the operating environment in this century. There's almost no overlap whatsoever. We're almost outside the bounds of previous experience, if you think of it like that. And to really rub salt into the wound, it's 2019. And it's not just that it was different, but it's actually the degree of difference that it represents. Absolutely huge. So it's not surprising. So we've got John and Rob and I in the audience, farmers from Murray Bateman. It's not surprising they were hurting. Absolutely radical difference between anything we've experienced before historically. So this is the world we're living in, and this is the world up as you go up to the top of that graph. That's the world we're accelerating towards. So this is, I think, really scary and really salutary. And you don't need complex analysis to show the meaning of this. This is extremely simple to understand in my mind. So it's not surprising that we've seen impacts, say, in the farming sector. So ABARES has been doing a couple of studies they did a couple of years ago, one on impacts of climate change on productivity. They followed up with this one this year and last year on impacts on profitability of climate changes. And if we look at that, all of our broadacre industry areas where we have our sheep and our wheat and our beef cattle, all of them have major hits in terms of profitability. And particularly down in the south, for example, Victoria, more than a third of profits lost due to climate change, but also up through the rest of the Murray-Darling Basin into Western Queensland, and particularly over in WA. So this is not a future scenario. This is what's already happening as a function of climate change. So it's unsurprising that our farming community are in pain. So moving very quickly to fires, because I know that Robert and also Anna Gregory kind of covered this a little bit later, but just a really quick snapshot from a climate point of view. So these fires made global news, as indicated by this headline down the bottom. I was in Portugal a couple of weeks ago, and everyone that I met, full stop, knew about the Australian fires. Whether it was a taxi driver or a waiter in a restaurant, they all knew about the Australian fires. They were all also asking, how is this going to change Australia's policy position on climate change? And I didn't have a good answer to that one. But what we saw last year was an early, official start to the fire season that was brought forward a month because of the extreme conditions that the fire chiefs were acknowledging at that point in time. But in reality, we actually had really serious fires right in the middle of winter, right through into spring. So it was extensive risk right across the year. We had record fire danger index in many places, not everywhere in Australia, but that was driving in particular that fire danger that was alerted months and months ahead of this red summer that we've experienced. Now, a fire danger index is basically a function of four things. It's a function of drought, which dries out the fuel and also causes leaf drop from a tree, so you build up the fuel load. Secondly, it's high temperatures for obvious reasons, it drives fires. Thirdly, it's very strong winds, which are actually a synoptic scale feature rather than a climate scale feature. But interestingly, the projections are for those sorts of conditions that we saw with our extreme fire days to increase in the future. So those types of synoptic conditions are likely to increase in frequency in the future. And lastly, dry air, which people haven't in the past started to really link that to climate change. So what we're actually doing, and I'll show you the next slide, is that the drought and high temperatures and dry air are very strongly linked to human-induced climate change. And the reason why I raised this last one, which is vapor pressure deficit, that's the dryness of the air, is that it's only recently started to be analysed, and this is the latest analysis of that. And what it shows is that globally, in spite of the fact that we're warming the air and warmer air can absorb more moisture, it's not doing that at the rate at which it could. And so there's a gap building between how much moisture the air can hold versus how much moisture it is actually holding. That's what vapor pressure deficit is. And you can see that particularly over the last 20 or 30 years, we've seen this really significant rise in vapor pressure deficit, and that's projected to increase significantly over the next decades. And this is not just important in terms of fire, it's important in terms of water resources, it's important in terms of agriculture, human health, etc. This is a really fundamental driver of climate which we've largely overlooked up to the current point. Now moving down to the local area. So some of you have got the climate coasters, which we've made in previous years. Previous years we used various types of timber. This year we're using recycled cardboard, and thanks to Mitch and Jeff who designed this and produced this. It's much appreciated. But what we try to do in those climate coasters is just encapsulate a year's worth of temperature data in a way that's relatable and different, so it sticks in people's minds, because numbers by themselves often don't stick. So if we actually look at Canberra, we had the warmest year on record, we had the hottest January on record, we had multiple days above 40 degrees last January, so we had 5 days in total, 4 days in a row, constant heat here. Nowhere near, of course, as bad as it was in many other places of Australia, but nevertheless bad for Canberra. And historically, if we look how bad it was, that whole 30-year period, 60 to 90, there was only 3 days above 40 degrees. So to give you a feel for how different that was. We had a dry year, but not the driest on record. Had extensive smoke pollution and dust, and Greta particularly will talk about that. But smoke pollution 20 times the WHO hazard level, is really, really problematic. And my throat still hasn't recovered, and my lungs still haven't recovered from that. So it's hit me personally. And on the other extreme, we had snow in a match, AFL match in Monaco. It was in August, and And I put that in not because it's climatologically or socially particularly prominent, but because the message that's been coming out for decades is that climate change will increase the variability, the risk associated with climate. So the hot conditions will get hotter, but also in some parts of the world, the cold conditions will get colder. The dry conditions and dry years will get drier, and the wet years will get wetter. So that range of possibilities is increasing, and that's why events like snow on an AFL game, the first time it's been recorded in Canberra, is actually important because it drives that idea that we're just dealing with increased variability and just not changes in averages. Now what we're seeing, the good news is that the population in Australia is broadly signed on to climate change. This is the Lowy Institute poll updated last year. 61% of people said it was a critical threat, we need to take action now, and I'm prepared to pay. There was another cluster of people saying it was really important, but not critical. They were prepared to pay, but not pay as much as the first group. And then there was a group, about 10%, who said no action until we're sure, so not signed on at all. But if you add the first two numbers up, there are 90%. More and more people apparently are shifting from the worried but not seeing it as critical group into the critical threat group. And in particular, when asked, climate change was rated to be the most important threat to Australia's interest over the next decade. So Australia's population acknowledges, understands, is worried about climate change. And this goes right across the globe. So we had last year the biggest climate strike ever, climate protest, with millions of people across the globe. I think it was 185 countries actually had representation in this climate strike. So, the weight of public sort of views on this is enormous, and almost any other issue would have politicians running to actually provide solutions to the public. If we actually look at business and business action, this is just a few of many snapshots and headlines that I could have grabbed, but like right at the top, fighting climate change will make you money. Stable climate may generate new industries. Big money is starting to abandon stocks, and particularly in coal, as investors look to the future. BHP ditched its coal-fired energy in its Chilean copper mines to take on renewables and paid a premium to do that, like $1 billion. BlackRock has said, if you don't take climate change into account, we're not investing in you, just ramping up their previous advice to investors. And I love this one, that firms actually link executive pay to carbon action. If you don't perform, you don't get paid, or you don't get your bonuses. Unfortunately, that's largely a European thing. It hasn't really stretched to places like Australia yet. But you can see that there's real action here. Even if it's not enough to tip the balance, at least it's a start. And some of it, I think, is really innovative, like producing not only aviation fuel that's carbon neutral, but potentially carbon negative, at the same sort of price point as existing jet fuel. So breaking that link between the flight shaming sort of issue. And that's the sort of innovation I think we should be doing here in Australia. We've got the brains to do it, but we're just not taking those sorts of questions on. We haven't got an adventurous enough science funding environment, in my view. If we actually look at what's, but it's really important not to look at this through rose-coloured glasses, is that it's not all good news. So, for example, we've got Sweden dumping Aussie bonds because we're not a reliable enough country in terms of climate action. We have most of the big firms across the globe being assessed as not being able to meet Paris Agreement targets. And that was a study of 3,000 firms across the globe. The one that I really like, though, a bit of poetic justice, is this one. It's just nice to sort of see this coming through every now and again. It'd be hard to sort of think about how they responded to that immediately afterwards. But you'd wonder whether they did that again. Now, looking at policy, because that's the big issue, I think, in Australia. So I just wanted to sort of look at a bit of imagination here. So imagine we were in a country that had a Zero Carbon Act or something equivalent to that. Imagine that we had mainstreaming of climate change into all major government decisions. Imagine if we had an emissions trading system that was sorted out and operational. Imagine if we had an independent climate change commission that drove information into different layers of decision making. Imagine if we had proposals to phase out coal rather than build new coal-fired power stations. Imagine if we had significant funding for our public sector, including defence, to reduce their own substantial greenhouse gas emissions. And imagine if we had substantial and strategic public investment in climate change mitigation and adaptation to forge that new R&D that Penny Wednesday was talking about, to re-life science, to give it street cred with people, to connect it more effectively with decision makers, so we can pool the knowledge together that we have across this room and across this nation. So this is my imaginary country. Can we have this? Should we have this?
Yes.
And we could have this, because New Zealand's got it right now. You only have to go across the ditch. Basically the same government system, the same sort of set of social and cultural norms, a better rugby union team. But they've actually got this now. They're winning, they're leading us. And we're so far behind, but we could have this and have it all. So just a few sort of key messages summarising. So climate change is not only going up, it's accelerating. And the impacts are increasingly being felt, and are being felt in things that we really value. There's both immediate and long-term strategic decisions and responses needed, investments needed. Many of the things that we need to move into that previous slide, that sort of imaginary world that I just talked about, are available, affordable and scalable. We can implement them now if we have the will to do so. And we need a supportive policy environment, though, to actually accelerate adoption of those things, whether it's adoption of electric vehicles, whether it's adoption of different farming practices, and Severity will talk about that later. But I think, importantly, the momentum for a just transition is building, and we see that in public surveys consistently across Australia. This is not about change that leaves people behind. This is about change that brings everyone along. And I think, importantly, climate change has to be moved away from a cost debate into an investment and an opportunity debate, because that's how we will be able to play and work together. Thank you.